All right, now that we've looked at how to find the correlation coefficient and exactly kind of what it does, let's look at some of the properties. So correlation needs to be between two quantitative variables. If you don't have a quantitative variable, this is not a process you can use. Correlation has no units, and we saw that was the case with the process of standardizing those scores. And because they have no units, the value of R doesn't change if we were to change the units. Okay, so if instead of measuring in miles per hour, I measured something in kilometers per hour, my R value would still stay exactly the same. Okay, so it's not going to change. Changing the order of the variables doesn't matter either. So if I highlight the first column and put a comma and then the second column, whatever R value I get will be the same as if I did it in reverse. So if I highlighted the second column, put a comma, and then highlighted the first column, I'm going to get the exact same value of R. The correlation coefficient is always between -1 and +1. So the closer it is to the -1 or +1, the stronger it is. The closer it is to 0, the weaker it is. The sign of R tells us the direction, and we'll look at why that's the case. There's a formula for that in a little bit, and we'll look at how that gives us that direction. And then the correlation is sensitive to outliers, and that should make sense if you think back to the beginning of the semester when we looked at the mean and the median and the standard deviation and the IQR, and we said that if our distribution is symmetric and doesn't really have outliers, we should use the mean and standard deviation. But if it's not symmetric or has outliers or it's got other problems, we should go with the median and the IQR. And that's because that mean and standard deviation are so sensitive to outliers. They can really the value gets dragged around a lot by those outliers. The same thing will happen to R because it's based on those things. Okay. So let's keep these properties in mind. And on your classwork, you're going to see these following problems. So there's a couple of different problems here, and you want to look and figure out what property or what rule each of these break. So thank you to pause the video. You can go back and look at those rules. In fact, I'll slide the screen back up so you can look at that and see if you can figure those out. And then we'll come back and go through. All right, so hopefully you took a look at that. The first one says the correlation between Olympic gold medal times for the hurdles in the year of competition is roughly R equals -0.66 seconds per year. So the problem with that is that R has units, and R should never have units on it. It should just say that that correlation is R is equal to -0.66, and that's it. Okay, the second one, the correlation between Olympic gold medal times for the 100-meter dash and the year of competition is R is equal to 1.37. Okay, so the problem with that is that R is between -1 and +1, and this is clearly bigger than bigger than +1. So that would be the error with this one. The third one, since the correlation between Olympic gold medal times for the 800-meter hurdles and the 100-meter dash is R is equal to -0.41, if we switch them, then my R will now be a +0.41. This is incorrect because it doesn't matter what order you put the variables in, it will always stay the same. So even if I flip them, I'm still going to get R is equal to -0.41. That correlation coefficient stays the same. The next one, if we were to measure Olympic gold medal times for the 800-meter hurdles in minutes instead of seconds, then we would need to divide by 60. Okay, that's false because changing the units does not change the value of R. Right, and then this last one, after conducting a survey at a pet store to see what impact having a pet had on the condition of someone's yard, a news reporter stated, there appears to be a strong correlation between owning a pet and the condition of the yard. So the problem with this one is that these are not quantitative variables. That question of owning a pet is probably either a yes, no, or it's like I have a dog or a cat or a goldfish. And then the condition of the yard, I would assume, is also like, beautifully manicured, mostly looks mowed, lots of weeds, something along those lines. So that would lend itself to categorical variables, and so we don't have the quantitative variables to make that